Yeah, I think last mile in particular is an area where we've seen an increasing focus on highly granular information. The pandemic certainly has accelerated trends that I don't think will surprise anyone. Last mile was a double digit year on year growth industry, and that's only predicted to increase. And that's kind of put a lot of pressure on being able to deliver accurate visibility. And I think it's interesting because we're beginning to see the knock on effects of that. It's interesting. We talk about the Amazon effect, but I think it's pretty clear that customer expectations have become increasingly demanding. This idea of the delivery person will be there, somewhere between 8 and 6 is just no longer acceptable. And that's meant that there's pressure to deliver in what is an already a very low margin industry. And, the average delivery vehicle makes 45 stops a day. That's dramatically increased in last mile scenarios. And that's where we see it's only getting worse. It's supposed to be in the next 10 years, we're looking at a nearly 100% increase in last mile deliveries with a corresponding increase in vehicles. Some have predicted as much as a 21% increase in traffic in urban cores alone in these cities, specifically due to last mile delivery vehicles who on average idle somewhere between 5 and 15 hours per week. So, where are they? Where are they going? What kind of variables do we need to take into account? That's where you really need to know customer availability. You need to know traffic. You really need to be able to put a lot of pieces together in order to deliver an accurate perspective on where the vehicle is and where the vehicle is going. And I think as retailers are increasingly pressed to take advantage of a shift towards online delivery, that's going to be something that will become even more important. I think at a high level.
Yeah, those are really great insights, Alex. And I'm just looking out my window at any given time. There's some sort of delivery truck from one of the major logistics companies or Amazon pretty much at any given moment, especially as we're heading into this busy shopping season. So it's more relevant now than ever out there. And from that, I think we've introduced why ETA is important. So now I want to dig into the science a little bit and the geospatial aspects and look at what are the variables that we need to have control of to be confident in these estimates. So we're going to look at that from both the middle mile perspective and the last mile perspective, because I think you'll see as we go through this presentation, there are very different things that we have to consider and be aware of. So, whether you're looking at a cross-country route where some goods are on the East Coast and need to make it to the West Coast or vice versa, as often is the case, or we are talking about just making it a few city blocks, but managing, traffic and construction that can pop up at a moment's notice, as those of us who are in cities are well aware. I'd like to look at what are the variables that we need to be aware of and how do they all play into this complex equation. So Amol, would you like to walk us through some of those?
Sure. So I think when we look at it from location platforms view, we try to look at it from a holistic perspective in terms of data. What kind of data fused together can give us accurate picture about the ETA, and it's going to be more complex when we put more modes in it. So if you only focus, let's say, on road, what we definitely look at or we have to look at is the kind of vehicle profiles, because heavy commercial vehicles they're average slow compared to cars and lighter commercial vehicles. So you look at those speed profiles. You look at road networks that they're allowed to traverse. So it's not always that you can put a heavy commercial vehicle on a busy street in a large city. You always have to ship the goods, somewhere on the express highways, and then enter them through, lanes in the city, and they're handed over. The goods are handed over to warehouse, and from that, the lighter commercial vehicles transport. So you definitely look at those. But what has increasingly become important is to kind of gather data about traffic along these cities in terms of historical traffic or traffic patterns, certain timetables allowed for these vehicles. Those definitely make impacts. But from here side, we again put a lot of efforts to collect dynamic data sets. For example, weather alerts or construction sites, even incidences on the routes. And those we try to kind of fuse them together through our routing and other services to create a better picture of ETA. And the same goes with the last mile. So maybe, Alex can talk.
Yeah, I mean, I think in last mile, the problem space is largely similar, but I would say one thing that you do see is a change in the vehicle profiles. Last mile is an area where we see, more two-wheel routing. So deliveries being made by scooters, for example, are more important. It's also, I think, where you're beginning to see, as we're looking at electrified vehicles, last mile electrification, I think, is a pretty big topic, and that's an area where understanding vehicle range becomes important when you're considering loading. Just understanding, where the customer is, geocoding and accurate geocoding and addressing, I think, is super important, particularly when you are looking at kind of second order optimization, I would say. So if you're talking about stop clustering, or you're trying to figure out what the best sequence of routes is to make these deliveries, and that's an area where I think, not to buzzword this, but I think that big data becomes kind of interesting here, and that's when you see companies deploying machine learning to analyze things like driver behavior, things like vehicle profiles, understanding that when you're looking at an ETA, how a light commercial vehicle behaves is going to be different from how a scooter behaves, or how a heavy goods, a heavy vehicle behaves. Not just because of the routes are different, but also because the driving times themselves are different, and you see kind of idiosyncrasies within drivers. There are, I have a pretty good relationship with my delivery person. They sometimes stop and chat, and that's not going to be necessarily the same for everyone. And when you are talking about trying to optimize an entire fleet, when you see companies looking at trying to move their distribution centers closer and closer to the urban core in order to limit the amount of time their vehicles spend on the road, being able to look at where your customers actually are, where your vehicles actually are, and also what the traffic patterns look like. Because understanding what traffic looks like at the moment is helpful when you're rerouting or planning routes for the immediate future. But understanding what they look like over time is what tells you, well, if we move our distribution center, or if we change these delivery patterns, that's where we can save time and cost and effort by taking advantage of just understanding how traffic really moves through the city.
Yeah, those are some really great insights, Alex. And I think what I'm learning here is that it's really not a one size fits all approach. We have to consider things like the vehicle in question, the road characteristics. And I think that's where here has a real strength from what I've seen, is we're getting down to understanding, what every lane of that highway is dedicated for. It's no longer just point A to point B, but all the little details of what's in between. I think, one of the interesting examples you guys were sharing with me ahead of time was you could take a given curve in the road and know that, all right, if we have an 18-wheeler, it's not whipping around that at 70 miles an hour, it's going to have to slow down. And that's the type of, I think, deeper insight that we're starting to use in these type of calculations that are making them much more accurate versus, all right, they're just going to be going 65 the whole way for 70 miles, and it's going to be about an hour, right? We have a lot more complexity going into the equation. So with that, moving along, I'd like to go on to question number 2, and that is looking at, we have considered all these variables, so what makes here unique in solving them? What is here doing differently than some of the other vendors out there that obviously are trying to solve the very same problems? So I'd like to hear from you, kind of what, from both of you, on what you find special about the approach that here is using.
Sure. So maybe I can start a little bit about, from what I have observed in the first and the middle mile logistic, is that, and I'm probably biased from, let's say, here's point of view. So we have a location platform which basically gathers data which is either static or dynamic. So if you look at road networks, they're basically static. So the roads and the road networks do not change over day to day. But what changes on it is the traffic. Monday's traffic flow is different than Friday's traffic flow, and so we gather both. It's the same way if you look at organizational or enterprise data. It has both static and dynamic data set. So if you look at Amazon's transportation network, it is fairly static. So they have warehouses around major cities, and then they connect those with trucks, or let's say from China, they might have a ship coming over and unloading stuff at the ports. But what changes then is that what kind of fleet is available for them, who is driving for them, what kind of driving pattern do we observe, aggressive, passive, Do they follow legal driving hours or not? So those are the things that keep adding the dynamics on it. So what here does is kind of create an environment where enterprises can bring their static as well as dynamic data set and combine it with our location platform or location data, which is both again static and dynamic, and then create value in terms of being able to accurately estimate ETAs, not just that, but predict it. Because once you have your networks kind of, organized on a location platform, once you know what kind of fleet is going to drive for me on Monday, on Tuesday, and Wednesday, you can create a fair bit of, patterns, and where you can create good estimates of ETA. And on top of it, if you can then create live data streams coming out of your mobile handset or your telematic devices and accurately match it with the route taken, then you can predict it. So that's the value. So everything, you can go, you can imagine it 2 days in advance, what you can get, what quality of ETA you can get, 1 day in advance, what you can get on the same day, and then at the real time, what kind of value you can get, and then slowly feed that back into your operations. So that is what we want to enable safely. I think then, I would also like to then request, Alex to kind of share lights how we create that difference in last mile as well.
Yeah, that's an area where I think, as I said, there are a lot of variables that go into that. A lot of things that we're talking about addressing, but I think the traffic side of it is actually really interesting because that's an area where, as I said, if you're looking at a 78% increase in delivery vehicles, that's something that you want to kind of be able to optimize around, balance, and that's going to be true both for fleets who are trying to optimize that, or for urban designers, urban planners who are trying to figure out what their road capacity is. So traffic becomes an important dimension for routes, and I think that is also an area where having this platform becomes useful because that's one of the most common questions I get is, where does the traffic data come from? Partly because I think you can imagine, if it was only coming from one source, there are particular SKUs there. We can all probably picture in your head some particular kind of mark of car, and if we only got speed data from those vehicles, maybe it would be 20 miles an hour faster than most of us would normally drive. And that's an area where blending different kinds of data sets together lets us smooth that out. So we take our, millions of traffic impressions based on truck travel, based off of companies who are using here in their embedded platforms. But there's also additional sources, right? So there are government sources, and all of that can be aggregated together to create a better picture of current and future traffic. So understanding what the instants are, understanding how road construction factors into that. This is something that changes on an hour by hour, and in some cases a minute by minute level. So the more granular data you have available, the more accurate your predictions can be, both when you're kind of, as you said, kind of future looking, what does things look like on this particular day of the week in general, or real time, how long would it take a vehicle to go 5 miles, or how far can a vehicle get in 20 minutes? Because when you're talking about being able to deliver accurate ETAs in something like an on-demand scenario, where you need to know what's the closest vehicle that can pick up something that needs to be delivered, that's going to be dependent on what the road network looks like. It's going to be dependent on bridge closures. It's going to be dependent on where there's traffic, where there's construction, what routes are even open for certain kinds of vehicles. All of that really needs to be aggregated, and that's I think where the real magic is how we can make sense of that data and then put it into action when generating these routes.
Absolutely, and definitely the granularity is making a big difference. I mean, you see on our screen here just some of the traffic events and closures in the area where AppGeo is based in Boston. And if anyone knows, driving around Boston, not the easiest city at first, but people get used to it. But a lot of that is that local knowledge of, all right, if it's the morning, I'm going to avoid this road because it's going to be backed up, but by noon it might be cleared out. And the idea here is and this kind of harkens back to our previous webinar on routing. The route that we choose is going to have an impact on ETA. How do we choose that route? Well, there's all these decisions that are made at the time of departure, and that's where this data comes into play. The other thing, I'll just cover this really quickly, but the fact that you said we can choose our vehicle type and profile, it's really going into that vehicle characteristics variable, where the one size approach doesn't work when we're talking. We can't treat the bus and the sports car the same, right? But so many routing platforms out there do. And that's obviously going to get very different results when you're trying to use it in a commercial perspective. So I think the fact that we can really dial in our vehicle profiles on a per vehicle basis even is really interesting and I think very exciting stuff. So going a little bit further now into this ETA concept, and I wanted to talk about what happens when things kind of go the unexpected, when there's a delay or you have an added stop or a deleted stop, when things change mid-route. How can customers best leverage that data into their solution? What are the things that they need to be aware of and doing proactively to lead to the best experience for everybody involved?
Sure. So I think this is a very important question because a lot of discussions stop at how do we calculate the ETA, but I think the real thing is how do we consume that. And for that, I think to begin with, we have to also look at how many times the ETA updates are required, really. Because if you, let's say, if you showed a picture of a long route where it is mostly or 80% of the time is just a long express highways where nothing changes as such. But, so there, what we have seen is that usually customers require fewer updates on those, maybe once or twice. But as soon as you enter an urban area, a busy city, you require more frequent updates because, at the same time, the warehouse operations have to start allocating resources for unloading, loading, and a lot of things also become more dynamic depending on the traffic, depending on the checking clearances and all of that. So I think the one thing that we have to look at is how many times the updates are required. And then the other thing is how do I respond to those? So there are two ways. One is, of course, how important it is for that ETA to meet. Because we have seen dwell time or detention time penalties, some financial cost attached to missing the appointment for loading or unloading. So what we definitely support or what we suggest is rerouting. So if there is a possibility to find a quicker and faster route, it is definitely the recommended action. In many cases, it is not possible because you cannot suddenly make a U-turn with your heavy commercial vehicle, turn back and take some other exit. It's not possible. But at least proactively passing that information that we discussed in the beginning, distributing it across the stakeholders, updating the new ETA, which are hopefully again more reliable, will also alleviate some of the concerns and some of the anxieties, making sure that everyone is prepared for the new arrival. So this is one thing we definitely suggest. And again, I think if you look at it from last mile, I think Alex can also talk a bit, is that passing that through the chain, where does it affect, where does it propagate to? So yeah, maybe Alex, you can add to, customer experience. Yeah.
Yeah, and I think this is the area where sort of everyone is familiar with it, and in fact, it's probably something that lay people are almost more familiar with because we've seen that change. We've seen that change between it's one of these things that like our kids are going to be mystified that people would stay at home all day and wait for a package, because we've seen those windows kind of collapsing. What customers consider as acceptable, and particularly when you consider that somewhere between most and the vast majority of customers will switch to a company that offers more reliable deliveries, or will not return to a company that misses a delivery. Being able to communicate those ETA changes becomes really crucial, because that's where people are expecting to see. You see at the beginning, you see when you order something, it says it'll show up at such and such a day. But then as the day progresses, you expect more and more finely, narrowed, refined ideas of where the delivery driver is, where the vehicle is, when to expect your shipment. And you begin to see as well, I think, more and more times customers specifying their own delivery windows, saying this is really when I want the delivery to arrive, which when you are talking about allocating jobs across everything in your fleet, those are things that you need to keep in mind. And that's where it becomes more critical than ever to have some kind of tools that actually take that into account rather than focused purely on estimation, on guessing, on driver local knowledge, on how long I think things should take. That's really just not going to cut it anymore.
Absolutely. And of course, this conversation goes broader than just dropping off a package, but it can also be those on-demand services that are, coming for an appointment at your home. That's becoming, increasingly common and valuable for the end consumer. And those are where, you really have to be there. I find it funny you mentioned the, kind of waiting all day. I can remember being a kid and just waiting by the mailbox from 10 in the morning to 4 at night when the driver would inevitably come, because you're that excited. And now, you can see a map of your neighborhood and where the truck is, and they're 2 stops away. It's a very different world in just a few years. And those are now, again, things that people are expecting and looking for you to offer as a retailer or a service provider. Moving on to question 4 here, and we've touched on this one a little bit, but I wanted to go even more in depth, and that is the topic of live traffic. So I'm curious, we talked about how we're using this data, but where is it really coming from, and how can customers be sure that it's up to date? For example, we don't want to get off the highway for a traffic jam that's already now cleared up by the time we would have gotten to it and then added time to our route. So I'd like to, talk about that traffic data a little bit and just get a sense of how you guys are doing that.
Yeah. So as I talked about this a little bit earlier, as you said. So the traffic data comes from a couple of different places. One of them is coming from the GPS data. So processing billions of GPS data points every day. And that that acts in concert with other incident reporting services, with data that we get from connected car sensors, from data that we get from smartphones or PNDs, connected devices that are using HERE services, fixed road sensors, smart commercial vehicles, and we are, I think, seeing an increasing reliance on vehicle telematics in the fleet space, as well as monitors for observing accidents in construction. That's something that changes, every day, and a lot of it is something that happens organically. I remember when we used to, we used to sponsor the Berlin Marathon here. I'm based in Germany, and I remember trying to figure out, let's make sure that we tag the road closures, and I was told, well, we don't have to. We just get that information. We're already ahead of that, and so here I was assuming it was going to be a huge deal. But when you have that kind of experience in figuring out traffic flows and being able to match those, then you get that sort of it sort of comes naturally. And so it goes beyond just you look at a map and you see, this road is green versus this road is yellow versus, this road is red and it's got some, node of construction or an accident on it. It really is understanding how all of that comes together, because there are sort of 2 ways to consume traffic. One of them is the real-time way. One of them, as you said, is, I need to figure out what exit to take. I need to know, should I be rerouted? But the other is, and, there's an implicit use of traffic there, right? Anytime you call routing, anytime you're using even the most advanced, the more advanced routing services that we offer, like here's Tour Planning API, are using the traffic data. But once you start building that out over time, the accumulated data then becomes available for additional analytics. So if you're trying to understand how is traffic actually moving through a city, we can tell you this is what the traffic picture looked like on a minute by minute level, anywhere where we're providing that kind of data. So we showed that in Hamburg a few weeks ago, where people were coming by and saying, the focus there was on sort of urban mobility. And when you're talking about additional mobility services, you're talking about bike rentals, you're talking about, new, smart trains and things like that. That all becomes part of a mix, and being able to say, this is exactly what traffic looked like at 4:05 p.m. in this part of the city. That becomes a really valuable tool, both to refine your models. Again, talking about machine learning, talking about that, which is always classically a garbage in, garbage out problem, and the more data the better kind of problem. So both for machine learning and also just for being able to provide appropriate location context, that historical data also becomes really key, ironically, for making better forecasts.
Yeah, I find that particularly fascinating when you think the average car is not just a form of transportation now, but it really is a computer in every vehicle. Probably several thousand times more powerful than the capsule we sent to the moon, right? So each of these computers is now networked together in some way or form, and that's the data that is helping us make these decisions, in addition to, as you mentioned, smartphones and sensors. It's a really impressive network of things out there that all feed together, and I imagine this also has implications in the self-driving space that'll inevitably probably be one of our future webinars as we go down the rabbit hole of topics. I want to take it to our next question, which is related, and it's something that you just mentioned on there, and that's this predictive ETA. So I find it interesting that we can not only know what the traffic will be right now, but at some time in the future. So can we look a little more in depth at, in our example here, I'm able to pick a calendar date in the future, in this case, like the day before Christmas Eve here in the US, and understand how, that date will change maybe my route or my predicted traffic, not only a date, but even an exact time. So if either of you wanted to comment on,
Sure.
How we're able to do that, because to me, that's even more impressive than looking out the window and seeing, okay, there's traffic now, right?
Yeah. I think so. I can again look at it from the transport and logistic lens. It's, as you said, it's being able to kind of pick a date and get a predictive estimate of arrival is something that we really definitely want to enable. But I think it goes, let's say there's some more to it. It's just not about routing, vehicle profiles, who's driving. It's about a lot of different data sources that you have to be able to combine, analyze, process, enrich, and then use it. So it's what we see is definitely the core data set that comes from our platform, but also again operational data sets that we want the shippers or other carriers kind of get and allow it to merge with our data set. So typically it's called the carrier integration or the fleet telematic providers that they allow from time to time to connect their fleets to a transport management system. And from at least what we have seen now is that it is just kind of a sending a GPS ping. But if you look at the historical data, then you have tremendous value in it to kind of process it. If it's purely training machine learning models with historical data set and then allowing that to match with the information that you're getting in transit and then predicting the ETA. So that is what we want to allow our customers to do. So to leverage their data sets from within different systems. So in Europe, you see definitely transport management system, but in US, it is more fleet management system that are connected and processing this information. And we see that there is potential to use that data to get better predictive estimates. And that is, yeah.
So kind of what you're explaining here is that if we have, say, 5 years worth of data and we notice on this one calendar date every year without fail, this 5 mile backup occurs, correct. That's something we can learn from when, expecting similar results on the same date in the future.
Absolutely. And we see that some of the largest retailers in the US or even in the Europe are actually doing it. It is because, of course, they have these large fleets and the data behind these fleets at their disposal. So they're truly leveraging it. But what we look at it is that democratizing this kind of functionality by allowing even medium or small size fleets to get that data set. So for example, field service management or workforce management systems to kind of bring that data and being able to kind of create value out of it. That's what we want to do.
Excellent. And that's going to take us to our last question for today, which is talking about the kind of end of the chain, that last mile problem, where we are, we've gone through the whole process of getting the goods or services close, and now we got to get them to the doorstep. So what are some of the complexities in that last mile, and how are major companies out there trying to solve this problem? When they're always competing to be the best and provide the best experience. I think we've touched on elements of this, but bringing it all together, what are consumers and fleet logistics managers really needing out there when it comes to this problem? And I think for this one, I'll pass it over to you, Alex.
Yeah, so I think the easiest way to sum that up is that in last mile, we're really seeing the chickens coming home to roost in a sense. This has traditionally been an area that's been quite low margin. It's been very expensive. Last mile is somewhere between 40 and 60% the cost of any given delivery in the supply chain. And this is an area where customer expectations have increased, keep increasing, past the point at which, being able to just say, I I can guarantee next day delivery is no longer good enough. Customers are pushing for same day delivery. They're pushing for on-demand delivery. They're pushing for visibility into where their drivers are, as you said, just looking and seeing on the map where the truck is, being able to being able to communicate with the driver. So the pressures have been increasing. And I think we're seeing that at the same time, a lot of the factors that have gone into kind of fleet structure are also beginning to raise their head. This is an area where when I am looking at how to plan a shift's worth of jobs, as I said, an average delivery vehicle will make somewhere between 40 and 60 stops on their route. If you round that off to 50, you have 100 vehicles. That's 5,000 stops that you need to be able to optimize. Optimizing, just those 40 to 60, that kind of traveling salesman problem is mathematically not possible to find an optimal solution for. You're already kind of doing your best guess, and when you're applying that to 50 or 100 vehicles, that becomes even more difficult to know that you're doing it appropriately. And so this reliance on manual processes, on human planning, this is something that can take hours. So I think there is a growing awareness that that needs to be solved. That creating a paper run sheet and handing that over to the driver based on what your dispatcher's best guess of how the delivery should go out is just not going to cut it. Both because fleets simply can't stay profitable, really can't stay operational if they can't optimize their performance better. While at the same time, it really locks off opportunities for growth. And I think will cause problems with transparency and visibility. So when you are thinking about questions like, what does, how are your drivers actually, behaving? What routes are actually being driven? If your fleet, if your rules say, and there's a huge driver shortage problem and driver onboarding is expensive and time consuming, but if your rules say don't drive through these zones, don't make these kinds of turns, make these deliveries in this kind of way, is the driver actually doing that? If not, why not? Are you basically creating impossible routes for your drivers to complete, which is something that is starting to percolate out? If you don't have the data to be able to answer those questions, then you can't optimize going forward. And considering the margins, considering the increasing focus we've seen on the driver shortage, on driver safety, on the shortcuts that drivers have been taking in regards to safety in order to make these delivery scenarios, I think the fact that customer willingness to pay is so low means that you have to be able to find solutions where you can. And there are aspects to it that really we haven't even started talking about yet. I think the realization that when we talk about the last mile, we're really talking about, on average, the last 5 to 10 miles. The average delivery is quite longer than that. When we talk about sustainability, these vehicles are not being used efficiently, and particularly younger consumers have demonstrated a growing awareness of and willingness to pay for sustainable delivery. So being able to stay agile with respect to these kind of changing concerns and changing demands, that's all going to rely on having a fleet that is completely digitized and business processes that are talking to one another, actually understanding these are the deliveries that I need to make. This is the driver that I'm going to assign them to. This is what that route is going to be, should be completed as, and if it wasn't completed that way, why? Where was it traffic? Was it weather? Was it that the customer wasn't in? Was it that something changed and the route needed to be reordered? Something like that. All of those things, answering those questions, reacting to them in real time, being more flexible, comes from being able to use location intelligence to actually understand what's going on. And I think that's by being able to have the information that we need to provide accurate ETAs, we create a better experience for everyone and a safer experience for everyone. We've seen that the pressures, particularly over the holiday season, are going to be pretty intense, and this is really going to be a pressure test for urban delivery fleets.
Wow, that you covered a lot of ground there, but I'm really glad you did. You really kind of opened my eyes to even more elements of the puzzle that are still to be solved in many ways. And just to touch on that safety note again, nothing is more costly than an accident when we're kind of crunching people for longer shifts and more deliveries per shift, that can be something that you lose sight of, and obviously not good for anyone involved if there's an accident. So again, by taking better control of all these variables, we can make that safer experience, that better experience. I think it's really a win-win to have this data in our pocket. One last little thing I'll touch on is, we talked about this last mile problem. I wanted to introduce our audience here to Routinize, which is an application that AppGeo has been developing, and it will be rolling out in the year ahead. And this is again a way to take that same kind of traveling salesman approach for multiple stops for a given set of drivers, and democratize it and make it good for small businesses who want to have this great technology with some good routing under the hood, and kind of put it to the test against their own delivery network. So you'll hear more about this to come, but just wanted to make sure you're all aware of our involvement in this space as a geospatial innovator. Now, again, this will probably lead into a whole nother webinar, but I think the big important takeaway here is that all the things that we talked about today are part of this larger ecosystem. It's not just one tool, but really a set of tools that work in tandem to deliver these great results. So Amol, if you just wanted to close us out by talking about kind of the value of the HERE platform and all the areas that it touches. And then, of course, we can go into this more in the future, but just so people are aware of how it all works together will be really interesting.
Sure. I think what we've seen is the trend towards software as a service. So what we have done recently, or in past 2 years, is that transform our really all our offerings as a platform and software as a service model. So the basic location data that what we talk about, the maps, the road networks, the traffic, all that data is offered on a platform. But to leverage that, we offer different kind of services which are cloud native. So there are web APIs that you've seen on the left, which basically cover the geocoding part. Like when you throw an address, it's converted into code, or a routing, or a tour planning that we talked in the last webinar. All these services are offered as a software as a service model. But also we try to cover on the edge for the edge devices. So the telematics tablets or the mobile phone apps, those are powered by some of the SDKs that we have. So Android, iOS, Flutter. So those we also kind of offer to our developers and customers to leverage the power behind location platforms. So that's the kind of a picture that we want to give to our customers and partners.